All right. Shh. Today is May 2nd.
Are we recording today?
Yes, we are. We are finishing section 10-2.
Okay, I'll be good.
I think I'm good.
Y'all are
I see that. Okay.
You're gonna miss us in the summer, huh?
are unique. Okay.
We love you.
We've already talked about taking log expressions, converting them to exponentials, and vice versa. Today we're going to work on solving logarithmic equations and inequalities. And it deals with the same stuff we focused on last week. Let's make this an 8. And the same concept as exponential equations. Last week in the test we took Monday, if this was an exponential equation, which it is that, it's called that because the variable is in the exponent, we said that we must first get the bases to be what? Equal to each other. Because if the bases are equal, then that means their exponents have to be the same. Now, one that a few students made, and I don't know if it was in this class, was that instead of turning 8 into 2 to the 3rd power, they somehow turned 2 into 8. Okay, they said 2 cubed is 8. All right, well that's like me saying, okay, here's a quarter and another quarter, and here is a $1 bill. Make the currencies the same, either all coins or all bills. They tried to turn this into a dollar bill. How can you turn 50 cents into $1 if it's only 50 cents?
You add more.
You can't do it. How can you turn 2 into 8 if it's only 2? You can't do it. Okay? You can only work with what is actually here. So, just remember that. You've got to take a larger number and reduce it to its factors. Not take the smaller number and raise it to its multiples. Alright, so here this would be 2 to the 2x minus 1 is equal 2 to the 3rd power. And once the bases are identical, then all we focus on are the exponents. Well, it's the same thing with logarithmic equations. Alright, the first ones that we're going to look at, you're going to have a log equal to a log.
What means that x equals 2?
This is a logarithmic equation.
So x equals 2.
So x equals 2 is absolutely correct. As if the log to the base of 5 has this solution, and I tell you the log of base of 5 has this solution, and they're equal to each other, then the solutions are what? Equal to each other. So x equals 2. Now what if I had this? If the logs and their bases are the same, then the solutions to those things are the same. And that's the equation I'm going to come up with.
If you have like log 6 of 2 and then like log 14 of 2.
We would have to make the logs the same. We would have to turn them into exponential equations and try to get the bases the same. Okay?
X equals -1.
X here is equal to -1. Now, does everybody understand what I'm saying here?
So what happens if we have different bases?
Okay, we're not focusing on that. Right now we're doing basic where the bases are the same. But like I just told him, if your bases were different, you would turn them into exponentials and then try to make your bases the same.
So like on the assignment we had yesterday, on the part with the logarithms and all that, we had to graph it and find the domain and range.
We didn't do all that. Y'all got to understand, that was last minute. I got a child with her head in a trash can sitting on a toilet, and I'm trying to come up with assignments, okay? And so that was like, hey, we did 10-1. Here, do 10-1, okay?
Are you really going to grade it?
Yeah, there's a virus going around in elementary real bad.
Can you not grade that?
It starts out with a headache and then before you know
Beat versus Beavers.
Okay.
Is that happened to her? Did it start
Wait, is it
already?
okay if we skip this?
No, she's been having a
We're
stomach,
recording.
she's been having a stomach issue since, sorry, Cassie, revealing your, issues there. You're only 6, you don't know the difference. Okay.
You'd be surprised. So are you gonna actually grade that?
Yes,
Wait, what about the ones we didn't do? Let's skip
completion
this.
and accuracy, I'm gonna take all that into consideration, okay?
It was just.
Don't just chill out, I'm not gonna be unfair, alright? When have I ever been unfair? Oh, yeah.
Like not making me top dog when I got 70.
You got 98 plus.
Huh?
You got 98.
Alright, let's solve this type of logarithmic equation. Okay, shh. Now this one does not have logs on both sides. This is a simple, this can simply be formed into some type of exponential, right? Because this is the base, this is the exponent, and this is the solution. Now we like our n's and x's to be on the right, on the left-hand side. So we're going to set it up with our solution n equal to a base of 4 raised to the 5 halves. Now, that means we simply have to evaluate 4 to the 5 halves. Now watch closely. Is 4 to the 5 halves the same thing as 4 to the 1 half raised to the 5th power?
Whoa.
Yes.
Yes, because this is a power raised to a power in which we're going to multiply the exponents, correct? You're not going to have to do this every time you solve. I'm trying to break down and show you what we have going on here. Now, Jordan, what is the 1/2 power the same thing as?
Square root of 4.
The square root. So 4 to the 5 halves is actually
72.
the square root of 4
That's not.
raised to the 5th power.
So how'd you write
Yes, 32.
So what's the square root of 4?
32.
The square root of 4 is 32.
Yes.
Everyone online, the square root of 4 is 32.
that? Wait.
No, it's not.
Oh.
The square root of 4 is 2, and 2 is being raised to the 5th power, which is 32. Listen to the question before you answer.
Yeah, Josh.
Think before you open your mouth.
Josh Myers.
All right?
Joe's mom.
Let's look at another one.
So the answer is 32?
The answer was 32. Let's say we have log to the base of 100 n equals
Long.
3 halves.
Ooh, it's the square root of 100 times 3, which cube.
Very good.
So it's actually 1,000.
Wait,
Good.
Whoa.
N is equal to a base of 100 raised to an exponent of 3 halves. Now, according to what we just said, the half means the square root of 100 cubed. What is the square root of 100?
10 cubed.
10, and 10 cubed is equal to
1,000.
1,000. So in this solution, n is equal to 1,000.
Oh, good. But so if we can do it in our head, do you still want us to work it out? I know, I saw that. That's what I was
So did you answer your own question?
More or less.
Okay. On the homework, you will notice it says no work equals no credit, no exceptions. Even if you can work it in your head, you still are going to show me some work because I want to see the process taking place
Oh,
in
it's
your
only
head.
odds in the back.
Because all the odd answers are in the back of the book. And I have students, and I know this is just unheard of, who just simply turn to the back of the book and list out the answers. Now, how does that help you?
No way.
Not at all.
Not at all.